This is the 2018 paper 2 question 18b. Now we looked at question A in the last one, very complicated. Now this one is maybe a bit easier, but it's still very difficult at the same time. We're given that the large carton has been redesigned so that both cartons are mathematically similar. The volume of the new large carton is 1,500 cubic centimetres. So we have to calculate the depth of the new large carton. We're going to use A and B for the depths. So the small depth is A and the large depth is B. We'll call V1 the small volume and V2 is the large volume. Just to be clear, this one on the right, the blue one, is the redesigned one. So we want to forget this part. So forget this in section B. So what do we know? So we know the information about the small carton. So we know that A equals 16 centimetres. And we know the volume of this one. It's 576 centimetres cubed. We don't know B, but B is what we want to find out, is the depth of the large carton. And we're told that the new volume is 1,500 cubic centimetres. Now they're mathematically similar, so we can find the volume scale factor. And there's two ways to do this one. The easiest one that I'm going to do is we're going to find the large volume divided by the small volume. So the volume scale factor equals V2 over V1. We have 1,500 all over 576. We then want to find the linear scale factor, so you have to take the cube root of this. Now to go from the linear scale factor to the volume scale factor, you cube, but to go the opposite way, you take the cube root, or that's the power of 1/3. So the linear scale factor equals this to the power of 1/3. And what we can do then is multiply this by the small depth. So you multiply this by A. So we say that the large depth equals 1,500 over 576. 576. And all of this to the power of 1/3 multiplied by A, or multiplied by 16. And if you plug this into the calculator, then you're going to get a value of I'm just doing that at the minute. we get 22.01 centimeters. The volume is just, sorry, the units are centimeters because we don't have a volume anymore. The other way you can do this one is to find, we'll do this one in purple. I won't go through this in as much detail because it's a less common method and most pupils use the one that I used in red. So we'll call it VSF. Never write this in the exam, always write out volume scale factor. I'm just doing this for shorthand. So V1 over V2. And to get the linear scale factor, you're going to take the cube root of all of this. And you're going to do the small volume, sorry, the small depth divided by this linear scale factor. And if you do that, you get the same answer. So if you substitute A in 16 and you substitute 576 over 1,500 all to the power of 1/3, you should get the same answer. So let's have a look at how the SQA would mark this. We'll have a look at the method in red. So the first would be to find the volume scale factor. So that's the 1,500 over 576. It's a mark. And the next mark would be to find B, which is the large depth. So as I have done, you take the cube root of the volume scale factor multiplied by 16 and you get 22.01 centimeters. The other method I described, you would get 1 mark for this is the volume scale factor, but the small volume divided by the large one, and you then do 16 divided by this. The answer would then be the second. But this one in purple is very confusing, so I would stick with the red one. And you had to show the working in this question to get the marks, because what they're assessing is your ability to convert between volume and linear scale factors. So you have to show all of the steps in that one. Another mistake that many pupils made was forgetting that you had to take the cube root of the volume scale factor. So many just plugged in 1,500 over 576. They forgot to take the cube root of that, then multiply by 16. Other pupils mistakenly thought that it was the area scale factor. So what they done was they took the square root of 1,500 over 576, mistakenly thinking it's the area scale factor, but it's the volume scale factor they have. And the third issue was accidentally substituting the large volume that was already mentioned in part A. So the 24 centimeters is now irrelevant. So that depth is irrelevant, and so is the 1125 centimeters cubed. So that information is irrelevant in section B. So I hope you found this video useful. I'll leave this one up. Thank you for watching and best of luck with the studying.